Hello viewers on YouTube. In this video tutorial, we are going to consider the proof of sine. So let's begin without any further ado. Let's consider a triangle. So let's label this triangle ABC. Now before we move forward, I would like to duplicate this triangle to this other side and have it right here as well. So I'll be making use of it anyway. A, B, C. Okay. Now, notice that this angle will be angle A, this angle will be angle C, and this angle will be angle B. Because we want to write it in geometric form, specifying this angle, you say it will be what? Angle A, B, C. So that's angle B. Okay. So if that is the case, let this side be lowercase a, this be lowercase c, and this be lowercase b. Same thing applies to this. Let this be lowercase a, lowercase c, lowercase b. Now let's take, for instance, we want to bisect the line AC or the line B from B, right? From angle B. And the bisection will be this way. Now, the bisection will be perpendicular to the line B or line AC. Then I will call that height. Let's call it H. The goal is to find H by all means. Now, for this other triangle, let's say the bisection we want to form is not from B to AC, but instead from C to AB or from A to BC. Either way, it will definitely work out. So let's consider from C to AB. Okay, perfect. So it will still be perpendicular or at right angle to line BA or AB. So I would like to call that height, let me call it H prime. Perfect. Now at this point, the goal is to find the value of H by all means. Now this triangle ABC has been entirely split into two different types of triangle. However, these two triangles that we have to be split into can be used to find the value of H. And we are going to be considering both of them. So let's begin with the first one. B part of B, C part of BA. So from triangle CB, then this part, let's call it M, the bisection. CBM, right? Let's call it M. B is not it. B is the length of AC. However, M shows us the point where this line H bisects AC. Are we together? From CBM, we have this triangle. Oops. Let me do it again. So this part is the H, this is A, and this angle is C. Don't forget, it's a right angle triangle. Now we know that the sine of C is equal to the opposite H over A. Now upon cross multiplication, or in other words, H will become A sine C. Let this be equation 1. Now for this other triangle, from triangle, that will be, let's call it ABM, and this one is CBM, that will be ABM. Okay, perfect. Then we have this diagram. This is still H, but this one we have C, and this angle is angle A. Good. Sine function, sine of angle A is still equal to the opposite H over hypotenuse C. Upon cross multiplication, or in other words, H is still equals to C sine A. Equation 2. But H is equal to H. So definitely we can set C sine A to be equals to A sine C. But we won't do that for now. Let's come back to this one. Okay. Now we said this line H prime has bisect AB. Now two other triangles has been formed as well. So these two triangles, we want to use it to find H prime. Let's focus on this one alone first. From triangle, let it be C. So this is M prime, this one. C M prime A. From triangle C M prime A, we have this. Okay. So we have B, and this angle is angle A. Then this is what is H prime. We know that, don't forget, it's still a right angle. The sine of A is still equals to what? H prime opposite over hypotenuse. H prime over B. Upon cross multiplication, we have H prime equals to B sine A. Okay. So let it be equation 3. So just put equation 3. Now for the other triangle, the one above, and we have from triangle, let it be C M prime B. C M prime B, we have this diagram. So it's to the right angle triangle. So this angle is angle B, then this hypotenuse is A, and the opposite is still H prime. So the sine of angle B is still equal to opposite H prime, okay, then divided by the hypotenuse A. Upon cross multiplication, H prime equals A sine B. Equation 4. Equation 3. Just make sure you keep that in mind. Now, H prime is equal to H prime in all cases because it will be of the same magnitude. Then definitely we can say B sine A is equal to what? A sine B. Okay. Now from this, we said A sine C is equal to C sine A. Okay. Now we also say here that B sine A is equal to what? A sine B. Also, B sine A is equal to A sine B. A sine B. Now for this one, that is equation 5, equation 6. From equation 5, I hope you are not mixing it up, or I should just get rid of some stuff so everything can be properly noted. From equation 5, let's divide all two by AC, the side AC, okay? Then we have A sine C over AC equals C sine A over AC. Notice that this reduce. Then we have sine C over C to be equals to sine A over A. Okay. Now in equation 6, let's divide both sides by AB. In equation 6, we have B sine A equals A sine B. So we are dividing 2 by AB, side AB, okay? Now B reduces, A reduces, and it implies that sine A over A is equal to sine B over B. Okay, but sine A over A is equal to sine C over C. So then we can still set this to be equal to this. That's if sine A over A is equal to sine C over C, then sine A over A would be equal to sine C over C, and it will be equal to sine B over B. And this is the sine rule. Now if we take the reciprocal of the function of any of the equation, notice that this will still implies that A over sine A, oops, I went to use capital letters here, they are small letters because they are sides. A over sine A will be equals to B C over sine C, and to be equals to B over sine B. So you can just rearrange if you want. And this is the sine rule. And that's how the formula is formed. In our next video, we are going to put into account how to use this formula to solve sine rule problems and also make good use of it. I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now.